So I still doing the theory sheet 6. I'll do question 7. Part H, which is ln of 1 over the 5th root of E. Remember, we are finding the exact value. So this is equal to the log of E if you want to see the base. And then it becomes 1 over E to the power 1 over 5. You can write as the log of E to the power negative 1 over 5. And then we know the power can be dropped. And then we have log E, and this is 1. So we get negative 1 over 5. Like that. So maybe we concentrate much on question 8. That was just a bonus. So on question 8, we need to use the laws. We are saying use the laws of logarithms. Write in simpler log form. Okay, the first one is log 7 and then 10 multiplied by a to the power 7 and then b to the power 3 and then c to the power negative 8. So you know, if there's addition, if there's multiplication, this guy is being multiplied by this one, being multiplied by this one, being multiplied by this one. So we have multiplication here, meaning for logs, we will have log 7, 10, and then plus. Then you cut the whole log, 7. A is to the power 7. So instead of writing 7 as a power, we'll write 7. So we'll drop 7 so that we save that time of copying this thing. And then plus the same thing will happen to B power 3. You start with 3 and then log 7B. And then now because 8 is coming with a negative, we say minus log 7C. And that's what is called simpler log form. Very easy. Look at B. B is the log. So the base is not mentioned, so we know the base is 10. If we want to write it, we put it. And then x squared plus 4, everything to the power 3. So what happens? So this becomes the log of z. Now realize that z is squared, so we drop the 2. And then plus the log of x squared plus 4. And we realize that this guy is to the power 3, so we drop it. And then we are done. What we don't have is the property that separates these. We don't have, and we should never try. So never separate the inside plus. What about C? It is ln of w squared, and then the 4th root of t power 3 over the square root of t plus w. Well, if it's multiplication, we split by addition, so it becomes W, and then we realize the W as a square, so we put the square here, and then plus the fourth root of t power 3 is the same thing as 3/4 as the power there, and then we leave t alone. And then this guy is down, so we subtract. And then the root is the same as half, so we treat it as half. The power, and then it has been dropped, so we remain with t plus w in this simple state. Okay. And then can you go to question 9? So these are bonus questions here. That's why I don't even want to ask you if you have understood. My assumption is that you have. Question 9, saying write each of the following. Write each of the following into a single log. So what we have A, 7 ln T minus 6 ln S plus 5 ln W. To write as a single log, if there's subtraction, you divide. If there's addition, you multiply. But you only do that after you've taken back the powers. So here we take back the powers. We take back the powers. So it becomes ln T power 7 minus ln T power 6, and then plus ln W power 5. Then now we have this guy plus this guy. So write as ln T power 7 and W power 5. And then this is subtraction. So we are dividing. That is S. Okay. So that is S. So we write S power 6. So this is S here. Right, S power 6 plus. So that's how we write this one here. Well, it's not different from, if you want, you can write it as ln T7 S negative 6 and W5. It's still the same thing. There's no big deal there. Then we go to B. B is half log the base not mentioned, so we know it's 10 if we want it. And then minus 2 log x minus 4 log y, and then minus 3 log z. Then we put this together. So we'll have log z plus 1 or half, first thing, minus, I'll open the brackets here and then do log x squared plus. So factor the minus goes to minus, minus, minus. So I factorize the minus and then have log y power 4 and then plus log z power 3, like that. And then now, first, I'll keep the z plus 1 half, and then put this inside here by multiplication and bring them together. So I have x squared y4 z3, which becomes log z plus 1. That half I can even decorate it by writing square root and then over this whole thing. X squared y4 z3. Like this. So we have composed it into a single log. If you have a question, you're free to ask. 2 log 3. Now the base is 3 here. Plus 1. Plus y here is the y. And then plus 6 log 3 x minus 1 over 3. Wow, if they are saying that we should write everything into a single log, then obviously we know that the first thing to do is to take back the powers. So we have log 3 x plus y squared plus log 3 x power 6, and then minus log 3 to the power 1 over 3. So you know, if it is just 1 over 3, it means that the log became 1 here because it was log 3. You know, this is 1. And why have you picked 3? Because other bases are 3. So you do that deliberately. And then now, if there's addition like here, this addition here will make us multiply these in log. So we'll have log 3 x plus y squared multiplied by x to the power 6, and then divided by the cube root of 3, and write as this. This is one thing. Notice what happened here. We had the constant 1 over 3, but they said we should write everything in a single log. So we had to introduce log here. And what log do you introduce? Log 3. So you know, because you know this is just 1. So nothing has changed. But I want you to help us write this thing as 1. Okay. So now I can look at the graphs. That will be an interesting thing. Yep. So go to the graphs. That's on question 10. What does the question say? Sketch a f of x is equal to ln of negative x. Suppose we have forgotten the families. What we do here is we let y be equal to f of x, and then we have y is equal to ln negative x. Now we know that when it is ln, the base is e, and then negative x. Then change it to exponential. Change to exponential. So when you change to exponential, it becomes e to the power y is equal to negative x. And then we can choose to solve for x, saying x is equal to negative e to the power y. So to the power y, then you pick the values of y. Let's pick the values of y. I will pick y negative 1, 0, 1. Remember what we have picked are the y values, and what we want to find are the x values. So what is y? I mean, what is x? Since our function is x, so what is x? What is x? When y is negative 1, so we get negative 1 over e. So negative 1 over e. And then the next thing is what is x? When y is 0, we have negative 1. Negative 1. And then what is x? When y is 1, so we have negative e. Put negative e here, and then put a sketch. So the values we have when y is negative 1, when y is 0, and when y is positive 1. So when y is negative 1, we get negative 1 over e. So somewhere here. And when y is 0, that is on the x-axis, we get x is equal to negative 1 here. And when y is 1, we get this guy is negative e. Remember, 2 point something. So it means that the asymptote here is the y-axis. So why it is, because we can't see an external letter there. So the graph is going to be of this nature. Like this. So this is f of x is equal to the mean of negative x. So remember, we have this family curves, but if you forget, then you can always use that table to help you remember. And as we said, the other functions, every time you see this function has the form. Let's discuss the forms after you're done with this one. Jonathan.
Sir, how did you get the y-axis to be the asymptote?
Because when we have the exponential, this is the exponential form. Remember, I said for the exponential form, if you are given f of x is equal to a plus b x, then this guy is a lambda asymptote. Now, what you are given here is some function. If we write it as f of y, we're supposed to be given a plus b y, and then say this is the asymptote. But what we have is a function x is equal to negative e power y plus 0. So that's why 0 is the asymptote. And this is 0 because the variable is y, so the 0 is the y-axis.
All right, I think I understood.
Okay. The next one is B. G of x is equal to ln of x minus 3. Oh, what's happening here? What's happening here is that if we let y to be g of x, then we'll have that y is equal to the log base e, so that is ln, and then x minus 3. Then again, we convert to exponential. So it will become e to the power y is equal to x minus 3, implying that x is equal to 3 plus e to the power y. Like that. Well, then now we know that the horizontal asymptote, I mean, is equal to 3. It's equal to 3. Which 3? This 3 is the y, means the x. Since this one becomes 0, contributing to y, so we just get 3. Since this one never gets to 0, so we'll never get 3. So x is equal to 3. Is the asymptote. And then what we want to find the x-intercept first. When x was the variable, we're first finding the y-intercept. Now we're finding the x-intercept first. So what's the x-intercept? You get it when y is 0. So we'll have 3 plus e power 0, which is 3 plus 1, which is 4. So at 4, we have the intercept. Then everything else is positive, so meaning that this guy is going to go like this. This is the function f of x is equal to the ln of x minus 3. So this is exactly the opposite of what we had, because what we had was negative inside. So then we reflect it when it is positive, it goes to the positive side. When the x is one that has a positive there. So if you understand exponentials, the only thing you need to add for you to be able to sketch logs is that you're able to convert from log to exponential, and then use the exponential properties, except you're switching variables from x to the y variable. Very, very nice.
Sir,
Hello.
so when finding the x-intercept, why didn't we equate the equation to 0? Or because you are considering the y?
Because the variable now is y. Only when you find the y-intercept, that's when we have to equate this to 0.
Okay.
So now what you have as a variable is y, and you know y is 0 on the x-axis.
Yes.
Yeah, that's why I was saying that y is 0.
All right.
And the next, so we're on C. H of x is equal to ln x plus 7. So let's see the difference. When there's a number inside ln and a number outside ln, what changes? So again, we let y be the log of e x plus 7. But this is one thing. Then we are converting. So the only way we can convert is when this 7 first is taken this side. So we have y minus 7 is equal to log e x. And then we raise it. So say e y minus 7 is equal to x. So our function x is equal to e y minus 7. And then what we do now, we can sketch. You've seen that there's no constant, so it is plus 0. So the asymptote is this line. And then from there, we move to the X-intercept by letting y be 0. Say e 0 minus 7. That is equal to 1 over e to the power 7. So this number is positive, but very small. So it's somewhere here. So sketching this guy, we put it inside and sketch it like this. Say this number is 1 over e to the power 7. It's literally just getting the intercept. That's all. Okay, so let's do some more. Let's see how D comes out. I'm trying to find if the one that will have an intercept for the y. D f of x is equal to the ln of x plus 2 minus 4. So again, we let y be the log of e x plus 2. So we take that guy this side. So we have y plus 4 is equal to the log of e x plus 2, and then raise it. It becomes e y plus 4 is equal to e y plus 4 is equal to x plus 2, which becomes what? So it becomes x is equal to minus 2 plus e y plus 4. Okay, so you've seen the horizontal asymptote is now here. This number here, negative 2. And then we'll have our sketch. So we have negative 2 x. So now it's no longer called the horizontal. We're calling the horizontal, right? Now it's the vertical. So for these, it's the vertical. So here, it wasn't here. For this, it's the vertical. Vertical asymptote. Why else do I call it horizontal? Okay, no, yeah. So it's the vertical. Yeah. Okay. And then now, we'll see what happens. When y is 0, what we get? We get x is equal to negative 2 plus e to the power 4. Remember, e is a positive at 2 point something. So 2.7, the minimum, to the power 4 becomes 53 something. So minus 2 is a positive number. It means that this guy will cross here so that it goes and crosses that side. And this is minus 2 plus e power 4. That's why I said you must always know that the approximate value of e is 2.7. So that when you see minus 2 plus e power 4, you know e has become too big. And then now we need to find the y-intercept. That is where now we equate the whole x to 0 because x is 0 on the y-axis. So we let x be 0 now. Then we'll have negative 2 plus e y plus 4. Then take to the other side. We'll have e y plus 4. Now to find y, you convert this from exponential to logs, so you can solve for y. So we take it back to logs, and then we'll say, okay, so this becomes log of 2 base e is equal to y plus 4. Remember how we convert? This is what you take inside, and this is still the base, and then the power comes inside. This implies that y is equal to minus 4 plus the log of e2. So this point here is the point -4 plus ln 2, because log e is the same thing as ln. Approximately, what is ln 2? Ln 2 is 0.6 something. Okay. Something important to check. I just checked out of curiosity. And so that's how it comes out. We still have E. I want us to do all the graphs here so that there's no excuse going forward. It's like we don't need to have people having excuses for not doing the right thing. G of x is equal to ln x minus 6 plus 2. So again, let y be equal to the log of e x minus 6 plus 2. We write y minus 2 is log e x minus 6, and then raised to the power is equal to x minus 6. Quickly becomes x is equal to 6 plus e y minus 2. So again, the asymptote, the vertical asymptote is this line, 6 here. And then to find the x-intercept, remember the x-intercept, we let y be 0. So this is 6 plus e power -2, which is 6 plus 1 over e. So put it wherever you feel like, 6 plus 1 over e. And then this means that there will be no y-intercept. So it goes this way because of the positive power x, or the positive power y. So in the quiz, in the test, you don't expect anything strange from these graphs. So expect graphs similar to these. And you must always be able to graph them. These graphs are very easy to sketch. They just need one, the asymptote. These are key things. One asymptote, 2, the y-intercept. If it's there, 3, the x-intercept. If it's there. Once you have these, then you can sketch. That's always how you sketch there, the graph. Okay, so the Zoom setup for 40 minutes. A minute to 40 minutes. So once logged out, you log back. So we can do from 11 and see if we can finish. And connect back. So let's do it fast, no break. No breaking. The MAT1120. Is my signature. But the first page. Fast, it's almost cutting. This is page 1. Oh. Difference. Oh.